Hi everybody. Here we have an example how to apply superposition to analyze electric circuit. Actually, this circuit that we have right now, I believe you cannot do anything but using superposition. Why? Well, just look at the sources. When you look at the source, you find this source, it's voltage source, the frequency of 15 hertz. And you have current source 30 hertz. So since you got different frequencies, the only way or the easiest way to solve this circuit is just to use superposition because you have different frequency of the supplies. So how you do superposition, as we explained in previous lecture, that you apply one source at a time. So let's just say you are going to apply the voltage source. So if you apply the voltage source, you set the current source equal to 0. So when you say this equal to 0 amp, it means going to be open circuit. So this is open circuit. That's first one. Then you apply voltage source. And since this side is open circuit, so there is no current and you don't want to calculate any voltage here, so you can just also delete this one. Or you should have this ground with you. All right, that's your reference point. And now we want to find the voltage across the point 1. First of all, to solve the circuit, you got to find the equivalent impedance of each element. First step, you calculate the angular frequency of the supply, omega 1. And you know omega is equal to pi f, and you are dealing with the first source called f1. It will be equal to 2 pi, and the frequency is equal to 15 hertz here. So you have 30 pi, and the unit, radian per second. After we found the angular frequency, then we'll start to find the impedance of each element. We'll start with the inductor, 1.5H. So you know that XL, in this case, call it 1 because we have omega 1 is equal omega L. And omega is equal to 30 pi times the inductor or the inductance, which is equal to 1.5 Henry. And you multiply, you get the unit in ohm, then you will get 141.4 ohm. That's XL1. Well, since we found the XL1, just go ahead and put the value of the impedance. We are going to use positive J or negative J, positive J because inductor, so JXL, so J 141.4 ohm. All right. For the resistance, it's just stay the same, 5 ohm, the impedance equal the resistance, that's fine. Now we're going to deal with the capacitance. So what's the expression for XC? It's 1 over omega C, omega 1. So B1 over omega 1 is equal to 30 pi, and C is equal to 10 millifarad, so 10 times 10 negative 3, and you calculate the reactance, which will be equal 1.06. You can say 1 ohm, but let's just use 1.6. Well, then you have the impedance value of this one will be equal to minus J because capacitance 1.06 ohm. Great. So the circuit now we want to find V1. It's like two impedance connected in series. So I'd like to represent like that to make it easy. That one in impedance, the capacitor, and I'm going to put the value. What is the value? Minus J, 1.06 ohm, and the other impedance, which consists of the resistance in series with the inductance. So you have 5 ohm plus J, 141.4. So that will be like the other Z. And you got the source, and it was given in root mean square value, which is equal to 10 on angle 0 voltage, root mean square, so are safe. Well, just to make it simple, let's just call this one Z1 and this one call it Z2, and you want to find, remember, V1. V1 at this node, what does it mean? It means you want to find the voltage across this inductor. Why? Across the capacitance. Why? Because this is the ground. When you measure the voltage from one point to the ground. So that's the voltage you want to find V1. All right. So Let me just call, since it's across the capacitance, so I can call it that's voltage across the capacitor. In the first case, call it VC1. How you find? Yeah. Do you know how you get this one? Yes, I can hear you. It's voltage divider, using voltage divider. So what's voltage divider? Voltage divider, we know that the voltage is directly proportional to the impedance across each voltage. So you can say that VC1 divided by the voltage source is equal, what is the impedance across VC1? Z1. What is the impedance across the whole source? The whole impedance, which is equal Z1 plus Z2. Great. So from this equation, we can say VC1 is equal Vs times Z1 divided by Z1 plus Z2. Do we have all values? Yes, we do. Just say VC1 is equal. What is Vs? The source voltage is equal, I believe, yes, 10 volts and angle 0. 10 volts and angle 0. Remember, that's root mean square. Z1, it's the impedance of the capacitance, which is minus J 1.06 ohm, divided by Z1 plus Z2. Just we have already Z1 plus Z2, 5 plus J, 5, that's Z2, 5 plus J, 141.4. And then you do this mathematical symbol complex. You can do it using the calculator. And what you're going to get, I got this value on the calculator, minus, it's a small number, 0.754 minus J 0.0027 voltage. Of course, we got to convert it to polar form. So the magnitude will equal 0.0755 on angle negative. Please check in your calculator if you get the same value. Maybe I had some symbol error or something. So that's the voltage across the capacitor when you apply the voltage source VC1. You got to convert this to instantaneous value. So how you'll do that? You will say VC1, you write everything now lowercase, because you are expressing the voltage across the capacitor as instantaneous value. You multiply 0.0755, this root mean square, multiplied by root 2 to get the maximum value. Then we agree that sine is the reference, so sine omega 1t. What's omega 1? I think we got it here, 30 pi. You can write it 30 pi, or you can write the value. If you multiply pi by 30, you get some decimal number. That's fine. T, omega t. And what's the shift of angle? It's negative 178 degree voltage. If you do that, let me just do the symbol operation on the calculator. It's still a small value, but that's what we got according to the values in this example. Square root of 2 times 0.0755. I got 0.1068 voltage sine 30 pi t minus 178 degree voltage. Just maybe you said, okay, we just multiplied the 30 pi, we got the value. That's okay. Let me just give you the value. I would make it 30 times pi. I'd like also to leave pi, but that's okay. 30 times pi. Oh, I'm sorry. T times pi. I got 94, so you can write 0.1068 sine 30 pi is equal 94.2 minus 178 degree voltage. We found the first one, function of time, and then just different this one. It's easy. Superposition actually is like you are solving two problems. Now, what is the second step? We found the voltage across the capacitor due to the source voltage that has 15 hertz frequency. Now I'm going to make a copy of the same circuit, and I will apply the second source, which is current source. All right, I did it ready to save your time. This is the original circuit. So you are going to kill the other source, which is the voltage source. If you make it 0, what does it mean? You replace it by, yes, what is it? Short circuit. That's right. So short circuit. Great. So that's the circuit you're going to solve. So when you think about superposition, is like if you have two sources, you are going to have like two separate problems. You have three sources, three separate problems, and in the end you add them. That's why we call it superposition. Simple. There is nothing in it, but you got to be careful. You got to look at the frequency, because every time you change the frequency, you change the impedance of each element. Right. Now, what is the frequency now? 30 hertz. So you'll calculate omega 2 is equal to 2 pi f2, and 2 pi and f2 is equal 30, which is equal to 60 pi. I will leave it pi. I'd like to save time all the time. Why you want to do it? When you do it in the calculator, it will calculate. Okay, that's omega 2. Now I look for the first element. I want to calculate the reactance of the inductor. We call it XL, and this time we call it 2 because we have F2. That will be equal omega 2 times L. Omega 2 is equal 60 pi, and L is equal 1.5 Henry. And here you go, do the calculation. We get 282.7 ohm. Great. So go ahead, change this one to impedance by adding plus 0 minus J plus J 280. Oops. But I have nice handwriting. 282.7 ohm. The resistance stays the same, 5 ohm, and what's left here, because the resistance don't change, just leave it. And you have 10 millihenry. They try to find the reactance of the capacitor XC2 is equal to 1 over omega C. That's omega 2 is equal 1 over omega 2 is equal 60 pi, and C is equal to 10 millihenry. That will be the way you write it. Let's do the calculation. You get small value in 0.53 ohm. Go ahead and change the value to impedance value, which will be minus J 0.53 ohm. You see, once you do this, consider yourself you solve half the problem. Then you want to find the voltage across one. So when you look at it, let me just make it like an impedance. So like I did last time. So you have the capacitance here represent as equivalent impedance. That's your Z1. But of course will be different values. Z1 in here is equal minus J 0.53 ohm. And you got the other Z, call it Z2. All right, which is equal to 5 plus J 282.7. Oops. And you see, and you have here current source. Now you tell me why I'm not going to do the resistance, because I'm going to use current divider, because this current is going through the resistance, entering the junction here. So the same value 15. So I say 15 on angle 0 amp. So that's why I'm going to use current divider. Then somebody tell me, okay, but you want to calculate the voltage here. I said, let's just calculate the current here, call it I1, and here I2. I am not interested to calculate I2. I want to find I1. So what I'm going to do, I'm going to do current divider rule. How you do that? Well, I'm going to say that I1 is equal the total current I source times the opposite impedance. What is the opposite impedance? If you want to calculate the current in this impedance, you multiply by the opposite one. This one, which is equal to 5 plus J 282.7 divided by the total impedance of the two branches. When I say total impedance in the branches, I mean this one. Don't include this one, because the current entering this node here, all right? That's the common mistake. Don't do it. So the parallel branches will have the total impedance will be equal to 5 plus J 282.7 plus the other one, which is minus J 0.53. What is the current IS? Okay, let me just move this one back, because I'd like to put the formula. So the formula I'm using, because some students like to have the formula, that's IS times the opposite impedance, which is Z2 divided by Z2 plus Z1, all right? What is the value of IS? The current source is given 15 on angle 0. 15 on angle 0. And because of the value, when I did that in the calculator, I found that's equal to 15 plus J 0.0005. So that's M. So that's the measuring part is so small, is like 0.1% of the real number. So you can round it to 15 M on angle 0. You got to take advantage of this one. Because if you have the real part 15 and the other one, the imaginary is just like that, you know? You make it like that. So when you make the resultant, well, nothing, just nothing. So just make it 15 M and acceptable. Because this one is neglected compared to 15. That's 15 on angle 0, by the way. Okay. So to find the voltage, okay, now here's the trick. If you want to find the voltage across the capacitor, you multiply the current by the impedance. You get the voltage here, V1, right? Y, Ohm's law. Current times the impedance, find the voltage. Okay, that's easy. And I'm going to call this one V. Oh no, it should be capital because I'm using root mean square. VC2 will be equal to, come here, I1 times XC. Not XC, Z1. Current is equal 15 on angle 0. You can write, that's current. Z1 minus J 0.53. You multiply and you will get 7.95 on angle negative 9. Why negative 90? Because minus J is equal 1 on angle 90. See, that's why. So that will be the value as root mean square voltage, just VC2. I wish to convert it to continuous. So multiply by root 2 times root 2 will be sine omega 2t omega in this case is equal to 60 pi. All right, that's easy. 60 pi minus 90. Let's just evaluate the value of the maximum value. So I multiply square root of 2 times 7.95. Then I get 11.24 sine 60 pi minus 90. And something interesting, you can put this one in nice form. If you have sine omega t minus 90, will be equal to minus cosine. So you can write minus 11.24 cosine 60 pi. You can leave it like that, all right? If you want to, or if you can leave it sine 60 pi, it's correct. But I'm trying just to tell you, if you have any angle or any sine or cosine plus or minus 90, you can always simplify it to one term to make it simple. But just some, maybe they want to make sure that you got the right answer. So I multiply 60 times pi to see what we got here. You can express this one. Just let me, sorry, just write this one also in a different way. 11.24 sine 60 pi is equal 188.5 minus 90. That's, I'm sorry, t. I forgot t. Oh, nobody say that. They got to have t. It's function of time, right? So, and we said that we can make it minus the value sine, not sine, I'm sorry, I make it negative cosine. Cosine, you can write it 60 pi if you wish, or you can write it 188, again. Why? That's important. T, don't forget it. Like at 188.5 T. Okay, so that will be the answer for the second part. Okay, just I will put on the side here just to remind you, sine omega t minus 90 equal to negative cosine omega t. Just if you want to know what we did. So what is the total? VC1 of t, I'm sorry, not VC1, the total. Now we want to find the total voltage. VC of t is equal VC1 plus VC2. Just simple, you put them. You don't add them, you just put, like now I have VC2, let me just put it here. It's equal negative 11.24 cosine 188.5 t. and VC1, I got it here. What is the value? Let me just make copy. I will not remember all the things, you know. So go there. That's VC1. And then just I will copy. It's equal to 0.0 and 0.1068 sine 94.2 T, see, T, minus 178. And that will be the total expression for the voltage. You cannot just, somebody say me, can we get like one value? No, no, no. They have two different frequencies. Two different frequencies, all right? So that will be the final answer for the total voltage, all right? When I get the problem, I'm not going to, of course, to get on the final, because maybe if you will get the final answer right, I just will grade it according to, did you understand the concept of superposition? Did you make two circuits with two separate sources? And then you just, I'm going to do it according to how we did it. Who got the right answer? Okay, I'll get in bonus, all right? Thank you, and you got to understand it very well. It's going to be in the exam, it's going to be in the final. Thank you. And if you have any question, just go ahead and ask me then. All right, see you.